So this topic is a little bit different from the topics that we've been having throughout the day. And this one is about machine-readable standards. A show of hands of how many folks love the way we publish STEP AP 10303. None? Oh, come on. I think it is the best thing since sliced bread, publishing thousands and thousands of digital files in PDF format, only to turn around and type them in or copy and paste or try and apply machine learning to them. No, this topic is a little bit different in that I'm part of a strategic advisory group that was just formed by the TMB in November of last year with a mandate to look at ISO's internal procedures for generating standards and really to face into the reality that so many of the standards today actually never see a human. They go directly from machine to machine. And the mechanisms by which that's done today are problematic at best. So that's what this panel session's about. So that was the question there, next generation of standards or just a new delivery channel? So, but before I get started, I thought I would start off with some introductions. These are our panelists here today. We have Olivier Marchand from EDF, Laurent Guisse from Schneider Electric, Etienne Caillou from AFNOR, and Jean-Yves Delaunay, who just sat down. Hi, Jean-Yves. And Christophe Castaing from EGIS. So please welcome our panelists. All right. So just a little bit, I talked a little bit about this, but maybe just to set the stage, the idea of a machine-readable standard, and it's interesting because terminology is everything, right? The idea of a machine-readable standard, so many companies, myself, my company included, take standards and consume them into internal systems. And so one of the things that ISO wanted to do was try and get clarity around the requirements that are coming from industry stakeholders like Boeing and like others, and to get a clear definition. And of course, like everything else in standards, getting a definition is usually the hardest thing. But then to work on a roadmap for this, what would one look like, and then what has to be the priorities, or what are the challenges associated with a machine-readable standard. And the entire point is to figure out how we influence ISO's strategic plan. This is going into, at the end of the year, ISO is doing their strategic plan in September. That's going to feed their 5-year roadmap. So the timing right now couldn't be better as we talk about smart manufacturing, smart standards, smart everything. And so to that point, this group is basically 2 members from each representative of the TMB. I'm there with ANSI. We have folks from BSI. We have AFNORs there. Right, you're on the group as well, and other countries who are lending their expertise to this. And so the panel session today is really about that topic. It's about, you know, what are we doing in our industry today as providers of standards, and how are we listening to the customer, in this case our consumer of standards, with the right delivery channel that they can use. So I know that a couple of you have some remarks, but then I think the others were just going to work off of a question and answer session. So why don't I start off with the prepared remarks, if I can get this thing to work. So we'll start off with this, and then we'll move through the other panelists.
Well, hello, and thank you for providing me with this opportunity of presenting what is happening at IEC regarding the machine processable standards. And I will directly give the example of It's more than a pilot because it's currently fully operational, which is the digital transformation of one series, which is the 61851. So maybe I should introduce myself a little bit better. So effectively, I work at Schneider Electric, and I'm leading what is called the MV Energy Influence, which include standardization, regulation, and thought leadership for medium voltage and smart grids. But besides this activity, which is internal to Schneider, I am also very much engaged in IEC, where I am convening a group dealing with data modeling for distributed energy resources and distribution automation, so including photovoltaics, electrical vehicles, storage, any type of renewable energies. I am also very active at the new Smart Energy System Committee. You know, IEC has set up system committees, and there is now a new Smart Manufacturing System Committee as well, aiming at favoring, I would say, the cooperation and the consistency between the activities of different standardization bodies. And in addition, I'm also a member of a very similar activity than the one presented just before at ISO level, which is this Strategic Group 12 of IEC, which aims at providing the IEC Management Board with recommendations for performing the so-called digital transformation. So let's just focus on this example, because I think from this example we can derive a lot of, I would say, requirements related to machine processable standard. So originally it was exactly the same situation than the one you have described. So we were in front of a standard well accepted on the market, but in a silly situation where all the users had to copy manually the content which was provided as PDF into their product, tools, system, whatever. So not only it was not efficient, but it was also very much error-prone, which means that it was just impossible to verify that this transcription into machine was good. And in addition, so what we have also determined is that the way the standard was produced was currently not efficient as well, which means that because it was not really relying on digital tools, it was performed manually. At the end, considering the complexity, it was just impossible to verify that what was published was without errors. So at the end, so it was in 2010, the decision was made to retro-engineer all the content and to go to machine processable standards, with the support of the central office, again, willing to get a real example for identifying the main issues. So what was the very first driver? First, it was to improve the quality of the standard. So this was the very first point, but we see that we de facto faced difficulty, which this process was cross-cutting the IEC organization, which meant that we had more than 15 different entities working on the same, I would say, technology, the same standard, and having the need of sharing, I would say, the same tools, the same file. So cross-cutting this, handling this cross-cutting issue was a first difficulty. The second point is that de facto, at the very beginning, we stated that we need multiple rendering. So which means that thinking digital would needed to perform or to publish the same content under multiple formats. And this is currently not really supported by the process. This multiple rendering also helped us to offer possibilities to download directly the machine processable file freely from the IEC website. So you can guess that there has been some discussion for reaching this point, but finally we came to a consensus that it was absolutely needed to reach all the supply chain, which means that we need to serve the purchaser, surely, the purchaser of the standard, but we need as well to reach all the different users of the standard down to the user, the end user, I would say. Especially because we had also to handle the question of managing changes. So if the purpose was to ensure the machine-to-machine interoperability, we have detected some bugs, really some bugs, and it was absolutely critical to fix the bug all along the supply chain, not only at the publication side, level. And this is why we have gone to the possibility of having free downloading for this purpose. And also we have developed internally to IEC web browsing of the content. So now there are, we have more than 15 different parts which can be totally and fully browsable by each of the different stakeholders. We faced real troubles regarding copyright and licensing also. I don't know if you have observed it, but if you buy today a standard, at least from IEC, I believe the same from ISO, but the first statement is that you are forbidden to make any copy of the content, which makes 100% of the user in an illegal situation. It was not that an issue, I may say, for Europe and Asian country, but in the US, the sensitivity on that point is much higher, and we had really customers which say, I'm sorry, I can't use a standard for that purpose. What we also have tried to do is to encourage the usage of draft standards before publication. Also, this is a new approach. Before the standard is published, we need to put this onto the market from some pilot, and this pilot to feedback the standardization process to ensure and to improve at the end the quality. Again, this is absolutely not the rule to have, I would say, a public exposure of draft elements. We need also to manage the change in a much more reactive manner. So we were speaking about a 4 to 6 weeks change process. This was, again, not that usual. A very important point also, it appears that the best model is a model which is done as close as possible to where the knowledge is, and not by the model specialist. So we have to think on a process where we can mandate, we can delegate the modeling activity as close as possible to where the knowledge is. So this is really a challenge today. We will see what it will lead to. And the last point, and there were some points of interest by IEC also as well, we have demonstrated that going through that approach, we can also open new business models for IEC in terms of subscription, for example, for having automatic notification of changes, for having automatic download of some parts and so on. So we can think about having, in providing to the user additional services, again, for a much better experience. We are still facing difficulties, definitely. So this was what we achieved more or less, but we still have difficulties. Managing the intellectual property, we still have cases where we were not cautious enough in managing the IP. And as soon as we speak of code, it's a little bit trickier. So the full supply chain requirements, so we have addressed part of the supply chain, but not all. So multiple rendering synchronization. So we are not that good yet in ensuring that all the different rendering are published at the same time, because it will involve different people in IEC. We have definitely some troubles regarding the use of software tools, which mean that if we produce digital content, surely there are behind some software tools. So who is going to manage such software tools? At current time, we are using a commercial tool, but is it something which is acceptable? Up to which level? What is the governance? Which quality insurance can we or should we associate to this? So we still have a question. And one of the major points which I mentioned here is support the translation. Up to now, translation is really downstream. If we think digital and we have multiple rendering, this won't work anymore. We need to think translation really at the upstream level. And then ensure that all the different rendering are effectively translated the same way. So I've started working with AFNOR. It is not that easy to set up. Now, if we want to enlarge the experience that we have seen, it's almost obvious that all standardization committee, technical committee won't go at the same speed. So we are currently thinking about setting up a maturity model in order to provide the right support based on this maturity evaluation. But globally, we believe that all technical committee will become partly digital. And I just provide here some examples. Definitions should progressively go to ontologies. Requirement should go to use cases, which mean digital representation of requirements. Characteristics, performance, everything should be also exposed in a digital format. So we believe at the end that any standard, or I would say 99%, should go in some ways to a digital exposure. We have a question of skills as well. So I already mentioned the need of setting up a team, a support, but this means also that we are able, this is not the case yet, to set communities within IEC, cross-cutting once more the different bodies. This is a real trouble today. We must still be very careful in not jeopardizing the business model of IEC. So it's a very sensitive point, and we have to be very careful in getting there, but we have as well to meet the market requirements, so we need to find a compromise between both. So it was mentioned, we have to adapt the process. So the strategic group 12 of IEC has all that goal, actually even more than that. So this strategic group, as I said, has the aim of providing recommendation to the board of IEC, but covering two aspects. One, which is to work more digital and to produce more digital. So currently, we have split the group into two parts, and I am co-convening the second one, produce more digital, which means machine processable element. And of course, we try to coordinate, so we have an ISO member, we have as well a Sensenelec member. We try as much as possible to finally come to similar conclusion, or I would hope identical conclusion with ISO. I don't see the reason why IEC should be so specific for not reaching the same conclusions. So, of course, all inputs are welcome. So if you have any willingness to contribute, so you can get to your national representative.
All right, thank you. All right. So up next, Etienne Caillou will share some remarks from AFNOR. There you go.
Thank you very much. Thank you very much, Kenny, and thank you very much also, because my presentation is going to be very shorter, because most of the content has been already said, and I guess within ISO, CEN, as well as AFNOR, we are still a step behind the experience of IEC yet. So few words about myself, maybe before. I'm Etienne Caillot. I'm in charge of standardization team within AFNOR, focused on environment and services in construction sector. I'm also handling the secretariat of ISO TC268, which is the technical committee on smart and sustainable cities. And I'm a member of different committees in BIM at both CEN and ISO level, as well as CEN and ISO groups on standards of the future. So just a few words about the standardization activities. Just to say that, as it has been already explained by Kenny and my colleagues from Schneider, our activities here within AFNOR, CEN, ISO, IEC, and other SDOs is to build consensus and make this consensus available to the market. So yet, as each industry, we are now facing our digitalization of our activities. So it's also a challenge, but as well as an opportunity as it has been presented before. So I will go slightly more in detail about what has been done yet by the ISO TMB, so the Technical Management Board, the governance board of ISO on machine readable standard. There is already some outputs provided to TMB, explaining already by Kenny. Today, our ISO deliverables are only focused on human as customer and not on machine. So today, we do have a lot of industries and stakeholders claiming for having a new kind of deliverable. And if ISO is not able to do that, there will be other actors that are going to do it instead of ISO. So it has been identified as a need. And in order to still be into the competition, it will be recommended, as Kenny said again, that ISO needs probably to develop a new kind of deliverable that could be an ISO smart standard for ISO smart machine applicable, readable, and transferable. We do have also similar initiative within CEN-CENELEC, because CEN-CENELEC has adopted in 2017 a project on digital transformation composed of 4 projects. One is against standards of the future, with 2 pilot sectors identified, because it's a different approach of seeing things within CEN, and they are wondering if one size fits all. So they try first to identify 2 sectors that are quite in advance. So oil and gas has been identified in construction as well. Both of these groups has already started to work. For example, the construction pilot group has started this work 2 weeks ago. So it's still we're still at the beginning. And then at national level, there is each NSBs that is trying to see, depending on each national context, and to collect their needs that relates to this kind of new deliverables that could be provided by standardization organization. So for instance, for AFNOR in France, we have collected a lot of needs, mainly from the publishing part of AFNOR, but also from the standardization part of AFNOR, especially within the construction sector, which has explained a lot of needs, which are going to be explained a bit by Christophe later. Again, when it has been also said previously today, when we are talking about digitalization, we need to recognize that this digitalization is really an item for our organization. So yet, within AFNOR, it has been done. So we are still now trying to organize ourselves first, prior to involve our stakeholders properly in order to have a consistent and coherent approach on this new potential deliverable. And just to be short, I have also included in the slide the different challenges that has been identified by the SAG machine readable standard of ISO TMB, because it's interesting to see that for now, within the ISO TMB SAG, when we are talking about smart standards, we will have to look at the scope. Does it relate to every standard or not? We'll talk about culture, governance, skills, processes, digital rights, cybersecurity. I don't want to go too much in details on all these aspects because it has been clearly detailed and explained in the same sense by my colleagues. But even if ISO is a step behind IEC, there is the same reflection currently within our organization. So thank you very much for your attention.
Thank you for that. And interestingly enough, I don't think we collaborated with each other before we came up to the, no, we didn't. So very interesting. Thank you for that. And then finally, one more. Christoph, yes. So Christoph.
Yes. Okay. So a challenge for you. You have 5 minutes.
5 minutes. Everything is
for 200 slides.
No. So I wanted to discuss about the question, the topic about boost construction. The challenge is, I'm going to go as fast as possible. The challenge is to create a European platform based on creating some services around the question of data dictionary. So data dictionary for us is very close to what you explained with Schneider Electric already. It's a question of data dictionary is to describe both things. First one is to describe how to understand the geometric element or object, and to describe semantics around object. And in the data dictionary, as it is developed by Smart, is you have both the question of properties in one hand, and describe the properties as that's the name of data dictionary, but also to attach the properties to object. Okay, and okay, I think that is common for everybody. The point is the following one: that we have created in France a group at the moment with some big players and some academic organization or some organization like AFNOR, including Schneider Electric, to be able to create a vehicle to manage the question of a data dictionary, which could be common for different standards. That means the standards described by Schneider Electric already, the standard developed by Smart, the standard developed by others like Senelec and so on and so on. The point is has to be based on standards which will be in progress to be accepted by ISO. The standard is 23386 to explain, to have a common approach of how to define the properties, and more to develop a workflow on the properties and object to describe what is the status of the information. And that could be useful and to be used by, for instance, IFC, because the problem is what we have on the standard today is to say that we don't want to only to manage 3D information, but we want also to manage semantic around that. And because IFC, for instance, is based on STEP and is very close to STEP 242, it could be very useful for industry like Schneider Electric, for instance, to have a common data dictionary or common network of data dictionary to be able not to duplicate for each standard the semantics, but to use a common data dictionary, machine readable, to be able to attach these semantics and the properties indifferently to IFC, to STEP, and so on. And if you come back what my previous presentation about the system of system, you will see that, for instance, for a railway system, to be able to attach indifferently semantics to STEP or to IFC will be a huge progress in terms of deliver the information like that. That means and the idea of this challenge is to create services around that in order to be able to provide the right information at each step of the life cycle of any project or works, and to be connected to the e-catalog provided by the manufacturing industry. And one of the services could be offered, which we very great in terms of, I give you an example, the question of handover and commissioning, because if you, in one hand you have the library of product as defined by the designer with the performance expected, and in second hand you have a e-catalog coming from the manufacturing with the same organization based on ISO 23386. That means we can offer services like automatic code checking to verify the compliance with what is delivered with the requirements. That means that in terms of productivity and quality of what we need to deliver will be great. So the issue is really to create a vehicle and to verify at the moment that there is a business model around that. There is some people, some organization ready to invest on that, and to be able to deliver a commercial vehicle, to be able to provide services and to maintain this information. And to give you just one example, I made a calculation yesterday after a discussion we have with AFNOR, that I give you the turnover in the construction industry for building only in France is 150 billions per year. The number of connected things is 150 billions. But if you go only on the issue about the building industry, I mean, a small building, a small house, is around 150 objects inside. 150 objects means 2,250 properties attached to that. If you take all of the life cycle in terms of preliminary design, detailed design, procurement, installation in terms of procurement, you have at least 7,855 transactions to verify that. If you come back to the global turnover of the construction, you arrive per year to 5 to 7 billions of transactions to verify that. So it gives you an idea. And the challenge of that is to compare what's happened with the telecom industry. It's more or less the same aspect. That if you go to the if you are going to a supermarket, you have already on the box some connected light system, but you have competition between that. They are not interoperable. And what we want to create with that is something equivalent to SMS and texto, to say, to have a common protocol to define the properties about the Internet of Things, of the things, in order to be able to have interoperability about the connected object. That is really the challenge we want to fix and to provide a solution. So we're in a situation to verify the business model around that and to see on the short term if it's possible to create a so-called vehicle for that.
Thank you. Okay. Finally, we've got two more of our panelists. I'll start with Olivier Marchand, and maybe just a short introduction and your thoughts about machine-readable standards.
Thank you. Je vais juste parler en français, j'espère qu'il y a toujours la traduction en route. Je vais commencer par me présenter. Donc Olivier Marchand, je travaille à EDF, je suis en charge de pilotage, de l'animation, de l'orientation de toutes les activités, toutes les implications directes d'EDF dans les commissions de normalisation pour tout ce qui concerne la production nucléaire et l'ingénierie nucléaire. Donc ça représente à peu près 150 experts, 150 ingénieurs d'EDF qui participent à un peu plus de 200 commissions nationales, internationales, ISO, IEC, CEN, Sénélec, AFNOR et autres, sur tous les sujets qui concernent quelque part le métier de concevoir, d'exploiter, de maintenir en fonctionnement de construire des centrales nucléaires. Donc c'est du génie civil, c'est du contrôle en service, c'est de la chimie, c'est des turbines, c'est de la mécanique, c'est de la métallurgie, c'est plein de choses. Donc ça, c'est le cœur de mon activité. Et puis depuis le 1er janvier 2019, je suis le chairman de l'ISO TC 85, donc énergie nucléaire, technologie nucléaire et radioprotection. Donc c'est un ancien comité ISO, il a été créé je crois en 1956, donc c'est assez ancien. Moi ça fait que 3 mois que je m'en occupe. Donc voilà, donc là je vais plutôt m'exprimer. Alors j'ai reçu en tant que président du TC 85 une enquête du TMB de l'ISO, donc me demandant finalement d'avoir une position. Donc cette position elle n'est pas définie encore au sein du TC 85, donc je vais pas beaucoup m'exprimer en tant que président du TC 85, mais plus en tant qu'observateur de la façon dont on travaille en inter-EDF. Alors ça a déjà été évoqué par Jean-François Hamelin, par Rebecca Toth, autour de la transformation de nos métiers autour du nucléaire au sein de l'EDF. Alors je vais juste prendre un exemple. Alors c'est peut-être caricatural, mais je pense que c'est assez proche de la réalité. Aujourd'hui, quand un ingénieur au sein d'une entité d'ingénierie d'EDF rédige des spécifications techniques pour rénover un système ou pour en concevoir un nouveau, il écrit un beau document qui va référencer, alors selon les cas, quelques petites dizaines, voire plusieurs dizaines de normes. Et quelque part, il doit essayer de s'assurer que dans l'ensemble des normes qu'il référence et de leur version et de leur année de sortie, tout ça reste cohérent. Et à chaque fois qu'une norme évolue ou qu'il doit faire évoluer finalement ses spécifications, il est censé reprendre quelque part la cohérence d'ensemble de son paquet de normes. Alors on l'a vu ce matin sur des planches très impressionnantes où souvent les normes entre elles sont liées, interconnectées, rétroagissent. Et donc aujourd'hui, c'est un cerveau humain qui est censé faire en sorte qu'il garantisse que finalement ce qu'il va choisir, ça soit bien cohérent, que toutes les rétroactions sont maîtrisées. Et lui, il va le faire. Et puis après, il y a un autre collègue qui reprendra plus tard, parce qu'une des particularités, mais bon, on n'est pas les seuls secteurs, le nucléaire n'est pas le seul dans ce domaine-là, mais c'est qu'en gros, entre la première fois où on écrit quelque chose et puis peut-être que la dernière fois qu'on va s'en servir, il peut se passer 100 ans. Puisqu'en gros, la durée de vie d'un asset nucléaire, c'est de l'ordre du siècle, entre le moment où on commence à l'imaginer, à le concevoir, quand est-ce qu'on va se décider à aller vers de la conception beaucoup plus approfondie, puis quand est-ce qu'on va le construire, et puis après on va l'exploiter pendant 50, 60 ans, on va le mettre à l'arrêt, on va le déconstruire. Donc ça veut dire qu'il y a plusieurs générations d'individus, d'ingénieurs, qui est censé maintenir cette cohérence d'ensemble sur des normes qui évoluent un peu quand elles en ont envie, ou comme elles en ont envie. Alors pas quand elles en ont envie, mais en fonction finalement des envies. Donc ça, c'est la situation aujourd'hui. Dans la transformation numérique de nos processus d'ingénierie, il est clair qu'une partie de ce travail-là va être fait avec l'aide de machines, pas par des machines. Alors c'est par rapport à ce qui vient d'être dit avant. C'est pour ça que dire finalement l'interprétation humaine d'une norme, il y en a certaines qui vont devenir de l'interprétation machine à machine. Moi, je suis plutôt sur des outils qui permettent à l'homme de se décharger d'un certain nombre de choses et qui se facilitent la vie via des outils de transformation numérique dont on a un peu parlé autour du programme Switch côté EDF. Et donc, moi, il me semble qu'effectivement, de faire en sorte qu'une fois qu'on aura rentré un certain nombre de nos millions de pages de documents dans un environnement très convivial et entièrement digital, de faire en sorte que ce système, toutes les exigences, toutes les évolutions de définition, que tout ce qui peut bouger soit capté un peu automatiquement par l'outil et que finalement il n'y ait que les anomalies, que les évolutions, que les choses qui peuvent mettre en péril ce qui existait, qui reviennent finalement à l'être humain pour prendre une décision, pour comprendre, pour faire d'autres choix, ça serait, je pense, un gain important. Voilà. Alors maintenant, il est clair que, comme ça a été dit précédemment, toutes les normes ne vont pas suivre ou ne vont pas être utilisées dans ce cadre-là. Et je vois, alors là je remets un peu ma casquette TC 85, clairement au sein du portefeuille de normes du TC 85, je pense que la plupart des normes, elles peuvent vivre encore à l'état de papier pendant assez longtemps. Je pense à des normes qui sont liées plutôt à des protocoles médicaux, par exemple, pour utiliser des sources radioactives. Donc là, c'est bien destiné à des humains, quelque part. C'est comment vous devez procéder, vous, être humain. Donc les transformer en normes machinables, quelque part, digitales, je ne suis pas certain qu'il y ait une plus-value. Donc c'est vrai que je pense que par communauté, par TC, ou sans doute par TC, de voir un peu le type de normes qui gagnerait à être rendu un peu plus facile d'intégration dans une machine serait sans doute profitable. Et donc on va essayer de mener ça au sein du TC 85 et au rythme du TC 85.
Great, thank you. Thank you. I do want to take a pause right now. I think, Laurent, you have a hard stop that you needed to leave today. So just wanted to briefly acknowledge that and thank you for your time here with us. And I know that you have yes, indeed. So thank you very much for that. And then finally we have Jean-Yves Delaunay from Airbus.
So it's not covering the full scope as the previous slides. It's more a focus. We have discussed this morning the importance of the digital thread, of the benefits to use the semantic of the information from engineering, manufacturing to support. But what is quite important is also to ensure the consistency, interconnection between the models we produce, create in the industry, but also the models of the standard part libraries. So more and more now we are working in the 3D model-based definition, not only on the 3D shape, but also on special disciplines, electrical, mechanical, composite, additive manufacturing, tubing, more and more. But what is quite important is that at the end, we have also standards for tubing, part libraries, electrical standard part libraries, mechanical standard part libraries, example fasteners, electronic standard part libraries. And that the properties, the semantic, can be checked between the models we create, part of the owned by the companies, and also the models of the part libraries. And it's now a very important challenge. So, and that should be based on standard part libraries, digital product data dictionaries, classification systems, and ideally based on international open standards, knowing that we may have other solutions provided by other consortiums companies. History, simplified history. So we have the standard part libraries created by the standard development organizations or by companies. Airbus creates their own standard part libraries. I am sure other companies also. And if we simplify the different generations, we had document-based, so at very old paper-based, then electronic-based, PDF. But what is quite important, it starts to be used, but in the future, it will be model-based. And if we simplify, we have really two categories of information. We have the metadata, the properties, the characteristics, and we have the models. And ideally, when we will purchase or develop a standard part library, we would like to have the metadata, the hierarchy of classes with the properties, but also the models. There will be several models. So when we will use a standard at the end, so the usage of a standard will be by the manufacturers of the standard part, and then hopefully we will have several manufacturers, and we will be able to select and to purchase. So when we will purchase, what we will want is to have CAD model, so the metadata, the properties, but also the CAD model, and there are the questions of the multi-representations. We will have still some special customization to our needs, but in the future we will have more and more simulation models to the standard part for some categories of standard part. So functional interface, kinematics, electric for electric simulation, EMI. So we have to imagine that in the future, we will not have only the 3D model representation of a standard part, but simulation models. A very important document, some of you, I am sure, are aware of it, but that it is part of our common background, is this document, and I know that some of you were involved, so it's a very good, it's a very useful. It's this ISO EIC database for product properties and classes, final report 2017, and it really describes the needs of this database for product properties and classes, and what we have discussed is in some way related with this requirement. And you have also a list of standards related to this domain, and as an overview, we have a set of standards, and we have clear links between these standards, and it's very important that we maintain the consistency. So it's the last slide, but it's to explain that if we want to have machine-readable standards, properties, characteristics, they have not only be shared in the product data models, like in the ISO step standards, they have to be also in the data dictionaries, and in the part libraries, and in the common data dictionary. And the EIC 61,362 is quite important. So we will have at the end a network of standards with close relationships, and they will be more and more in the future digital or model-based, and we will have to maintain the infrastructure for the evolution of these standards. So we have also to understand that if we want to take benefits of machine-readable standards, we will have also to ensure the longevity of this infrastructure. And it's not an easy problem.
All right. Thank you. All right. So I want to thank the panelists. Yes, I know that you have to leave, so thank you very much for participating. We have just a minute or two of our scheduled time, and so I have just kind of one question. First off, thank you for sharing the different perspectives around the challenges we face. As you reflect on where we're at as a standards community in serving our market, and you were forced to pick the biggest challenge we face, what would it be and why? Our biggest challenge. First one to the mic wins.
Je pense que ça a déjà été dit en fait dans la journée, et je pense que ça s'appliquera malgré ce que j'ai dit en disant que on devrait amener quand même du progrès et faciliter le travail des humains. Je pense que ça reste la transformation dans la tête humaine. C'est-à-dire que les gens aujourd'hui ont pris des habitudes. Je pense que ça a été dit sur comment on passe finalement d'un univers documentaire plus ou moins papier à un environnement purement digital. Et je pense que donc il faut arriver à ce que quelque part celui qui a le savoir-faire, moi j'ai un peu donné une vision peut-être un peu caricaturale de l'ampleur de la tâche pour assurer la cohérence de quelque chose, mais les gens qui savent le faire, c'est leur savoir-faire. C'est vachement important pour eux, quoi. Et donc de dire que maintenant une machine va faire 95% de ce qu'il faisait, et puis certes il va leur en rester 5%, mais il faut arriver à les convaincre que ces 5%-là, ça va leur permettre d'acquérir, d'avoir encore plus de valeur pour l'entreprise. Et ça, à mon avis, c'est un grand challenge. Pour passer ça, et je pense sur les exemples qui ont été montrés dans la journée, il faut trouver des quick wins, il faut trouver des victoires rapides. C'est-à-dire qu'il faut, sur certains sujets, c'est pour ça que je pense que la démarche d'essayer de typer quelles sont les normes qui devraient évoluer les plus vite ou les secteurs, des choses comme ça, je pense qu'il faut aller vers sélectionner finalement les sujets au sein des comités ISO, IEC, où les utilisateurs vont vraiment trouver une plus-value immédiate, parce qu'aujourd'hui c'est quand même plus de contraintes que de plaisir, et s'appuyer sur ces gains, sur ces victoires pour faire un peu de prosélytisme et par l'exemple convaincre. Je ne crois pas du tout aux démarches très globales, très génériques, très abstraites, où on va promettre le bonheur, le grand futur, tout sera mieux dans le futur parce des gens veillent sur votre bien-être et feront des choses qui amélioreront votre travail quotidien. Je pense qu'il faut que les gens soient convaincus de ça pour franchir le pas. Ça sera peut-être plus simple avec les générations futures d'ingénieurs qui auront grandi avec des outils digitaux dans les mains, qui auront un smartphone greffé à l'oreille et autres. Mais ce n'est pas encore le cas des gens qui travaillent aujourd'hui, pas de tous en tout cas. Et donc voilà, donc je pense qu'aller vers des victoires rapides, justement, c'est un moyen de passer cet obstacle qui est quand même ce monde du virtuel, il fait un peu peur quand même, le monde du virtuel. C'est autant les objets concrets, les objets que j'écris, les papiers, je sais ce que je fais, je sais ce que je dis. Là, c'est une machine, quelque part, qui gère plein de connaissances à ma place. Et donc voilà, donc pour passer cette peur un peu, ce qui est pour moi un obstacle au progrès, il faut s'appuyer sur des exemples et des victoires.
All right, with that, thank you very much. And unfortunately, we've hit our time for our session today. Again, let's have a big round of applause for our panelists.
Thank you very much, Kenny. It was a very comprehensive session. So I'm calling Alban Schmutz to share his concluding remark.
So, hello everyone. So it's not an easy task. So I've been asked to do a presentation not in 20 but in 10 minutes. To give you the opportunity to take the bus for those who will be able to enter the Airbus facilities. So thank you for being here until now. So I'll introduce myself. So I'm Alban Schmutz. I'm in charge of strategic development and public affairs at OVH. Maybe a lot of you in the room do not know about OVH. So I will explain a little bit what we do. So OVH is the largest European cloud provider. And so I will explain a little bit what we do and how we do it. Our interest in the standardization topic, even if we are not very involved in standardization bodies, and also share with you some, I would say, astonishment remarks regarding what I heard today, all of the day, and maybe wondering why also some topics were not on the table. So very quickly, OVH is a cloud provider, so you probably know better our main competitors, naming AWS, Google, Microsoft, and some others. Nevertheless, OVH is the largest European cloud provider. We are currently managing 360,000 physical servers. It makes OVH the only European players in the top 10 worldwide. And we basically, in our DNA, we have openness. And I think openness is the key point regarding working together in standardization body. Here it's, I would say, a standard presentation of the company, but saying, okay, we are working on simple things, multi-local, so being able to work with our customers where they are. But what is more important here is to make things accessible, transparent, reversible. So being able for our customers to leave when they want. They can join it, for sure. But they also can leave when they want, and we think it's a very key value on the market, and it's a way to implement standardization in a certain way, since openness is something very key here. So to save some time, I won't go about the OVH history, but just 2 words on that. It's a company started in 1999, so 20 years ago now, almost, and today operating in more than, I would say, we have customers in 150 countries, but we are operating with teams in more than 20 countries now. What is interesting in the field of today is what is our business and where we need to invest regarding the standardization topics. So we are running servers at scale. We are building also those servers. So OVH is not a customer from IBM, HP, Dell, or so ever. So we have our own production lines, and OVH is the #1 customer of Intel in Europe. So every day we are producing between 300 and 500 servers, so physical machines, in our production lines. We also own our own dark fiber network worldwide. So we are totally vertically integrated to be able to deliver all the added value to our customers. That means that we need to rely on standards to some extent in all the value chain, and we need also to focus on what is our unique added value on some topics. I will come back to that very quickly also. Just for those who do not know the company, we are not, I would say, a SaaS provider or an AI company or a data company today. We are an infrastructure company, so we are producing servers, data centers at scale to help our customers to bring their data, their value inside our data centers, and being able to help them and not being their competitors. And that's why we have several, I would say, brands and lots of stuff. So we are producing bare metal servers, cloud platform as a service, etc. So we are, for example, one of the key partners of VMware, of Microsoft, or some of all the other stuff. But I think it's not very important here today. So regarding the topic of standardization, as I already mentioned, we are not member of actually of any standardization body, but we do work in that field. So maybe it's like poetry. We are doing something without naming it. And and there are, I think, two main fields where we are acting in that topic. There are what I mentioned on all tech and industry topics. When we say industry is, okay, we build data centers, we build servers. So this is, I would say, traditional industry we are in, so we need to work in this field. So we are interested like on, I would say, open hardware projects, for example, where it helps us potentially to bring things faster at scale. We are also interested in, when I say tech, is we are producing tools for our customers to leave us. So you want to take your workload outside of OVH, or maybe outside of any of our competitors. We produce open source tools for that to make this possible. So it's something very important. In industry, we also eat our own dog food. For example, so we are managing servers at scale. So each of our servers, we have some, I would say, some IoT devices to measure temperature and all those things. So we developed platform as a service to be able to handle, for example, time series regarding that at scale. And we give it to our customers directly also. We work on another field that is the regulatory environment. It's something I didn't hear much about today. So I will come back also on this topic. And for us, all this is to achieve two major key goals. One is market openness. And market openness is not just, I would say, something that is nice to have. If we are entering a market, I'm speaking here for the cloud market, where you are entering an oligopolistic situation, it's very dangerous for the ecosystem, for OVH as a company, but for our customers who may be locked in, so it's a very major threat, and for all those startups or key players that can bring value in that ecosystem, and where other companies may have, I would say, the ability to give life and death to someone. So it's something very important. And the second one is to deliver things at scale. So, as I mentioned, we are producing a lot of stuff, and every single, I would say, service at OVH should be available to be delivered in 120 seconds to our customers. So it's something to be able to bring at scale is very, very important. So I just take here an example of what we do in terms of regulatory work. We are not working in a standardization body, but for example, we gathered a group of 30 competitors to develop a code of conduct regarding the General Data Protection Regulation. You would tell me, okay, it's not industrial data, but you will understand the link after that. The General Data Protection Regulation asks the market to be able to build codes of conduct by the industry that may be validated by the regulatory body, so the European Data Protection Board. So it's not a standard, it's something that is asked by the regulation, where I would say a regulator can put a stamp on it, and where the European Commission may give a general validity across the Union. That's something very important. It's something we started, I would say, three or 4 years ago now. And the link with the standard is, to make it very quick, GDPR is rolling out far across the borders of the European Union. So most of the South American countries adopted the GDPR. Many other countries in Africa or in Asia Pacific are changing their rules to adapt to the GDPR. And using such a tool as a code of conduct to become a standard is something that may also be a support to that. And we already have been, some standardization body already asked us if we would be interested to turn this code of conduct into a standard. So something quite interesting here, just to open the discussion. So I think I have 2 minutes left. So I will be very quick. So I think you were here all the day, so I will be very quick. I think the risk that big players of data will be there and propose something in your field is something I heard. I think it's maybe one of the most important things. Perhaps behind the fact that cloud is a key factor of success. But, well, sorry, it's a joke. Maybe more interesting perhaps for you is what I think I didn't hear today. And I think we are in a world that is changing very fast, and the geopolitical instability and the threats behind that are very key. So even if we are working in an open world to build standards, we need to take into account this perception to be able to manage this properly. And for example, one of the things I didn't hear today at all is the mention of the free flow of non-personal data regulation. So it's a new EU regulation that came out end of last year. So you all heard about the GDPR for personal data regulation. But in the frame of the European Commission, they have this European data space, and there is the other sister regulation, free flow of non-personal data regulation, on the Article 6, who is only on data portability, saying that customers should be able to leave easily one provider to go to another. And the impact of this regulation is at least the size of the impact of the GDPR worldwide. So it means that you have a regulatory tool today where the legislation across Europe, so the 28 countries, maybe 27, will have to apply that. And one CIO here will tomorrow be able to ask its vendor, okay, why don't you apply the codes of conduct that are asked by the regulator? And it's not only in Europe. So if a CIO has the right to move its data easily from one provider to another here, and I'm not speaking only about infrastructure as a service, but also software as a service, where you are all impacted here today, the same CIO in Australia will have the same question with their vendors. So it's something very, very important, and I think it's something that needs to take into account when you speak about industrial data and standardization. I think this is very important. And it's not only something that will come. I would say the group defining those codes of conduct started to work almost 1 year ago now, and I think none of the people in the room today are involved in that. I'm co-chairing the infrastructure as a service group on this topic, so there will be a code of conduct regarding infrastructure as a service, another one regarding software as a service, and maybe other ones. And regarding infrastructure as a service, we have customers involved. For example, a customer organization like EuroCIO, so gathering CIOs across Europe, is co-chairing this work with me. And we're going to issue this code end of June, so very soon. But I think more industrial people should be involved today. So I would just finish here, giving this to you, and I'm happy to have the discussion right now or in the bus if you want.
So thank you very much. It's 59, so it's not so bad. But I encourage you to go outside and take the bus. Thank you very much. Have a nice evening.